Thank you. Okay, as far as our agenda for the evening, it is going to include an introduction to the project team that we have here with us, some project history and background, as well as the overall project goals, some perspective about how the project fits into the larger context of the Botanical Garden of the Piedmont, the hows and whys of stream restoration, and the details of this particular design process, our next steps and our timeline for moving forward, and then finally we'll have time to answer your questions. Before we go any further, I'd like to introduce the project team members that will be participating in the meeting tonight. Besides myself, we'll be hearing from Jill Trishman-Marks, who is a landscape architect and the executive director of the Botanical Garden of the Piedmont. Jill, thanks so much for being here with us tonight. And then we have some team members from Hazen & Sawyer, who is the city's engineering and design firm for this project. From Hazen & Sawyer, we have Kevin Middlebrooks. Kevin is an environmental scientist and Hazen's technical advisor for this project. Thanks, Kevin, for being here. We have Ty Smith. Ty is a professional engineer and Hazen's lead design engineer for the project. And finally, we have Ryan O'Banion, and Ryan is an environmental scientist and Hazen's project manager for the Schenks Branch Tributary Stream Restoration Project. Thank you all for being here tonight. And now, while not part of the presentation tonight, I do want to take a minute and make sure and mention the larger project team that we have been and will continue to work with on this project. And that includes city staff from our Parks and Recreation Department. And in particular, we've been coordinating with them on the pedestrian bridge and the trails that will be coming to the garden, our Public Works Engineering Group, our Utilities Department, and our Neighborhood Development Services Department. Also on the project team, obviously, Botanical Garden of the Piedmont. In addition to Jill, we've had the pleasure to work with members of the design committee, as well as the board of directors. Water Street Studio from right here in Charlottesville, and Mick Young Kim Design, who are working with Jill and her team to design and implement the Botanical Garden. And finally, the Virginia Department of Environmental Quality. That's an introduction to the project team. And before we go any further, we've got a project site map here to show you that for those who aren't familiar with the geography of this portion of the city, I want to just take a minute and orient you to the project site. Schenks Branch Tributary is a stream located in the eastern portion of McIntyre Park, near the intersection of the John Warner Parkway and Melbourne Road. And this is the portion of McIntyre Park that houses the Botanical Garden of the Piedmont. The reach of the stream that is the focus of this project is roughly 850 linear feet, and it is represented by the yellow dashed line on the map. It extends from the railroad right-of-way down to the John Warner Parkway. And now a little background about how we got here. Schenks Branch Tributary is a stream that has been experiencing active and very severe stream bank erosion for many years now. The picture on the right in this slide is Ty Smith in the stream collecting data last summer. And we found from this data collection and from our experience that some of the stream banks along this reach of the stream are as high as 12 feet tall, with exposed bare soil along those banks that gets washed away during storm events. Data collected by Hazen as part of this process estimates that 436,000 pounds of soil gets eroded away from the stream's banks every year. And this sediment gets washed downstream to waterways that are considered impaired by the Department of Environmental Quality because of excessive sedimentation. And this includes Schenks Branch, just downstream of our project, Meadow Creek, and the Rivanna River. And this results in extremely poor habitat for aquatic organisms, and it also makes the stream very difficult to access for recreational purposes. And as I mentioned, this isn't a new phenomenon. This is something that's been going on for years now. And it was recognized to be enough of a problem that the project was initially identified during the East McIntyre Park design process back in 2014, 2015. The notion of restoring the stream was also included at that point, I should say, on the East McIntyre Park schematic plan, which was adopted by Charlottesville City Council in March 2015. So a study of the stream was called for as part of the phase 1 design work, and a concept plan for the restoration was completed in 2016. The project was then included in the Botanical Garden of the Piedmont's schematic plan in 2018. And so with that, in late 2018, the city applied for grant funding from the Virginia Department of Environmental Quality's Stormwater Local Assistance Fund, or the SLAF grant program. Funding to help support the project was awarded to the city in 2019. So then in 2021, the city hired the environmental engineering firm Hazen and Sawyer to assess the current condition of the stream and design a restoration approach that will bring the stream back to a stable and a healthy state. So finally, I'm just going to touch on the project goals before I pass it on tonight. And you'll notice that the goals of the project are very closely tied to the background and the history I just discussed. What we want to do with this project, first and foremost, is improve water quality. And we'll do that through stabilizing the stream's eroding banks and bed. And this will reduce the amount of pollutants, such as sediment, also nitrogen and phosphorus, from flowing downstream into Schenks Branch, Meadow Creek, the Rivanna River, and eventually Chesapeake Bay. We also want to increase and improve habitat for aquatic and streamside plant and animal species. And we'll accomplish this by including design elements in the stream itself that will provide habitat for fish and insects, and also by planting the streamside area with plant species that are native to the Virginia Piedmont region. And then finally, we want to promote educational opportunities and allow the community to have improved access to and enjoyment of the stream. So the restored stream will become an important part of the Botanical Garden of the Piedmont. And in that, we'll be able to provide a unique opportunity for the community to interact with and see the benefits of stream restoration. So with that, I'd like to go ahead and hand it over to Jill Trishman Marks, Executive Director of the Botanical Garden of the Piedmont, to talk a little bit about how the restored stream will fit into the larger context of the site and a little bit more about the garden itself. So Jill, please take it away.
Thank you, Dan. We really appreciate the opportunity to be part of this presentation this evening. Can we start the slides, please? Thank you. For all of you who aren't familiar with us, Botanical Garden of the Piedmont is located on the northeast end of the McIntyre Park East. Next slide, please. Our mission is to invite all community members and visitors to engage in nature, to educate and inspire through the beauty and importance of plants, to advance sustainability and promote human and environmental well-being. And you can see our vision is below that. Next slide, please. To orient you on this drawing, the road at the bottom of your screen is the John Warner Parkway. Melbourne Road goes up towards the right top corner. The railroad track is at the top of the screen. And then you can follow the boundary down the left-hand side. So the red line that you see outlines the boundary for the Botanical Garden. And what this schematic plan drawing illustrates is whether you're entering the garden from McIntyre Park East, from the skate park or the Vietnam Memorial, or you're coming from the trails along the John Warner Parkway, or from Charlottesville High School up Melbourne Road, the stream cuts the garden in half and is always going to be an aspect of the garden that visitors will encounter. And it also will be a major draw into the Botanical Garden. So enhancing it with this stream restoration is a great, makes a great asset in the garden even better. Next slide, please. So we started stewarding the site in 2019. For those of you who are unfamiliar with it, it was the former leaf dump and mulch pile for the city of Charlottesville. So when we began taking care of the site, it was a lot of garbage to remove as well as invasive plants. So this photograph is that actually at the garden when we first started penetrating into those invasive vines. Next slide, please. The clearing of the site enabled us to develop spaces for educational programming in the garden. And we've been offering bird, tree, butterfly identification programs, as well as other educational opportunities in the garden. Next slide. And the stream is also one of the outdoor classrooms that we have been developing as we grow the programming in the garden. We received a grant which enabled us to develop an educational aspect to this stream restoration. We're working with the Ravenna Conservation Alliance as our partners, and we've been out in the garden with scouts and students testing the water. And the plan is to continue this water testing during and after the stream restoration. The results of the water tests are available on our website. And so we'll be, one visiting the website will be able to watch the historical transformation of the water quality over time as the stream restoration goes on. Next image, please. And we will also have educational signage about the stream restoration. So the signage will include what is a stream restoration, who benefits, what is water quality. So we're just looking forward to making this another opportunity for the Botanical Garden to be able to educate the community about something that's going on in the local environment. So you can contact me. At the next slide, you can see my phone number and email address. So if you have any questions about the role the Botanical Garden is playing in the stream restoration or just the Botanical Garden, please do feel free to contact us. And thank you again for this opportunity.
So thanks, Jill, for that explanation and background on the Botanical Garden. So my name is, as Dan mentioned earlier, I'm Kevin Middlebrooks, and I'm one of Hazen's corporate stream restoration leads. And I want to talk a little bit about the stream restoration design process, particularly, why do we perform stream restoration and how do we perform it? And then I'll hand it off to Ty that'll talk more in detail the Schenks branch tributary restoration. So next slide, please. So first, why do we perform stream restoration? Well, simply streams are important. They convey stream flow and storm flow across our landscape. They create habitat and food sources for aquatic and forest creatures. They supply drinking water and recreation for people. And as Jill mentioned, in this context, they provide educational opportunities as well. And we perform stream restoration to address some form of instability within the system and to improve water quality in the streams and tributaries of Schenks Branch that are part of the Chesapeake Bay watershed. It's a challenging but very rewarding process to be able to sort of come into an impacted setting, come up with a plan with a variety of stakeholders, and then see that plan through fruition. It's an exciting process, but it requires careful consideration of the stream and the surrounding watershed to form the goals for what can be accomplished. So the reason that contributes to these impacts is, there's a variety of activities that influence the stream instability, both, sort of more modern and historic. Urbanization and other historic impacts really change how the water moves through our landscape. And this means a higher volume of water flows to our streams at a higher rate. compared to forested or undisturbed conditions. And our streams respond to that by eroding to accommodate this change, which then causes impacts to ecological systems. And that's what we're trying to address. So the good news is that there are many established procedures and methodologies to perform stream restoration. And next slide. And Hazen uses a variety of those procedures. We start with a methodology that first focuses on understanding, the stream system to understand and define those project goals. So as Dan mentioned earlier, the goals for this project are to improve water quality, to enhance stream habitat, and to promote educational opportunities. So once we establish those goals, we perform a variety of field assessments and analysis to understand what the challenges and opportunities are. And a big part of this is understanding and building upon what others like the Botanical Garden have done in the past to leverage that local knowledge and investment to inform our plan. And then finally, particularly at Hazen, we look for low impact, sustainable solutions that are going to be resilient to changes over time. And as I mentioned, we use a variety of design methodologies depending on the goals for the project. But for the Schenks branch, we're using an approach called natural channel design that's endorsed by the EPA, by the U.S. Fish and Wildlife Service, and it's approved by the Chesapeake or for the Chesapeake Bay TMDL water quality compliance. Next slide, please. So natural channel design really seeks to establish a stable dimension. So on the left-hand side, so sort of if you're looking at it downstream, the pattern, how curvy or how sinuous is the stream, and profile. So that's the combination of pools and other shallow, slow-moving deep water and fast-moving shallow water, or pools and riffles in the stream system. It requires careful planning and construction to accomplish the project goals while also minimizing disturbance. So at Schenks branch, we'll stabilize the eroding banks by grading. We use construction equipment to grade the banks to a more stable slope. And when we perform these activities, we're careful to manage disturbance to a fairly small localized area. And typically that's around 200 to 300 feet, because that's generally what could be temporarily stabilized, say a large storm system moved in during construction. Once that grading is complete, we'll then seed the banks with a native riparian seed mix, and then cover the banks with an erosion control fabric that's made of natural materials. It's biodegradable. And in addition to these practices, we also use a variety of structures within the stream. So a key component of natural channel design is sizing and shaping the channel that will accommodate the current and anticipated stream and storm flow. And this, along with these in-stream structures, ensure the long-term stability of the stream. So these stream structures are constructed of stone that is sized to resist movement during storm flows, but also trees and other woody material that we harvest on site. And they serve the purpose to deflect flows away from the stream banks to prevent erosion, but they also provide that habitat complexity, as I mentioned earlier. So the deep, slow-moving water, the pools, and also the fast, shallow water, and really it's that habitat complexity that creates sort of the refuge for fish, and also the riffles create habitat for aquatic insects that the fish feed on, that sort of thing. So the key here is we use a variety of structures for both stability and to ensure that habitat complexity. And then finally, a really important part of stream restoration is vegetation. So trees, shrubs, and herbaceous plants in the root system hold the landscape together to prevent erosion. And they also serve an important habitat function. So we prepare a riparian revegetation plan to go in and revegetate those areas that have been disturbed during construction, and we focus on preparing a native, diverse species. And we also consider the landscape setting when selecting those plants to ensure that we're putting the plants in the right space, that where they receive the right light conditions and the appropriate soils and amount of water to survive. And there's many different plant guidances and documents that we use to inform this. But again, the key here is the vegetation serves a variety of purposes, both to help with the stream stability, but also to provide the habitat enhancement that is important goal of this project. So that's sort of a bit of the kind of high level of what is stream restoration, why are we doing it, how do we do it. And I'm going to hand it off now to Ty to talk a little bit more in detail about the Schenks Branch project.
Yeah, and thank you, Kevin. Thank you, Jill, for providing a little bit more context, and Dan identifying some of those projects that we talked about early on. And so I think that we've gone through, the 30,000 foot view and talked through the theory as well as the goals for the particular project. And so now I'm going to spend some time talking about how we're going to be implementing these goals through our design and through construction. So as Dan and Jill already mentioned, the project is within McIntyre Park, within the Botanical Gardens of Piedmont. It's about 2 miles away from the grounds. And effectively the flow is starting from flows in the direction of the left side of the screen to the right, where we're effectively, the Schenks Branch tributary falls underneath the Norfolk Southern Railroad and then continues on underneath John Warner Parkway to Schenks Branch onto Meadow Creek and down into the Rivanna River. And as Dan mentioned earlier, our particular stream restoration reach is in this dashed area that we've identified here between the railroad and the roadway. And these two particular components really lock in our project's longitudinal extents and dictate the upstream and downstream area from which we can start this particular project. But beyond that, there's also urban infrastructure considerations that are present throughout our project site, including natural gas lines, which are indicated by these yellow lines, stormwater control and conveyance style features, one of which is an existing BMP, where I'm hovering over right now, as well as sanitary sewer, which locks in the left side of our stream restoration reach between the sanitary sewer and ultimately the steep and forested hill slopes to the right. And so as you can quickly see, the working area to complete the project starts with understanding our site, our important assets, as well as those constraints before we can effectively develop an area for which to perform the work. And so really what I want to draw your attention to is this highlighted or expanded area here that effectively shows where we are planning on performing this particular stream restoration area. And we believe that this particular designation here meets our overall project goals. It minimizes disturbance, and it also facilitates future public accessibility. And it's all well and good to look at it from a 30,000 foot view, but I thought that maybe I could take you on a quick little tour through the stream too. So where we start the restoration reach is actually right at the natural gas easement, and that's where this 360 photo is located here. And you can note some of the hoof erosion along the left bank. As we move downstream, this effectively shows typical conditions where we have active erosion and undercut banks, which is jeopardizing the vegetation and tree canopy that run along the stream bank. You can also see a longitudinal bar that's effectively showing a diverging flow and lack of habitat complexity in these long meandering pools. In the next station, you can continue to see the similar conditions where we have vertical stream banks that are primarily consisting of clay and silt with minimal coverage, so it's actively eroding and exposing the root mass that are along the stream bank, in addition to presence of invasive species and continued lack of habitat diversity. As we continue to move downstream, I'll show you a quick picture of the tributary that's coming into the project site. So this is an interesting site where it's actually an active head cut that's moving up the tributary, and it's starting to actually reach bedrock. And because it's hit bedrock, it's actually starting to widen now too, and we're experiencing and seeing active failure and felling of the trees. Moving down a little bit further, here you can see what's resulting in it within the main center of the tributary, where we have those actively failing banks, felled trees causing blockages, significantly tall banks with active erosion stream banks contributing to sedimentation, and then continued lack of habitat complexity and low vegetation, which kind of looks like a gully in nature. And last but not least, just about where our project ends is effectively where there have been riprap stabilization improvements right at the John Warner Parkway Bridge. So this video and the stream walk effectively tells a big story where it might seem that, from the stream bank, everything might seem fine, but actually when you get into the stream, it tells a different story. And the big takeaways that I want to draw your attention to again is active stream bank erosion, lack of habitat complexity, and low vegetation coverage to minimize and mitigate continued erosion along the stream banks. Now, the good news is that we've developed a plan that has effectively met all the goals that Dan introduced you to earlier. And what I want to do quickly is identify and locate some of these important structures that Kevin introduced you to earlier. So first off the bat is our grade control structures that are consisted of riffles, cross veins, and log J-hook veins. And these generally look like what you see over here on the right-hand side of the screen, where these cross veins can be built with stone or wood. In this particular instance, we plan to use stone, whereas with the J-hook veins, we are planning on constructing them with log material that's harvested on site. And what's great about these particular features is that, as Kevin noted earlier, is that they provide habitat uplifts while also providing vertical and lateral stream stability. The other great news is that we've identified an opportunity for introducing a waterfall, falling water feature like the master plan had identified earlier, and we cited it where we believe that it makes a lot of sense while also providing stabilization and effectively a view shed from the active area within the park to this really important and cool feature. The other important aspects that I want to draw your eye to is we're going to be installing effectively tow wood structures and soil lifts. Now, what these types of structures do is they effectively are placed in outside meander bends, which are generally high stress areas and stream networks. And what these do is they actually provide increased habitat. They reduce down effectively stream power and high stress velocities that are moving through here, and also allow us to tie into very vertical stream banks in a more stable fashion. Now that I've spent a little bit of time identifying where these particular features are going within the landscape, I want to talk about how we're actually meeting our goals. So to meet the water quality goals, first and foremost, we're actually performing this stream restoration approach by effectively stabilizing the stream banks. And the great news is that our particular stream restoration design is exceeding the original estimate for pollutant reduction. And so what I want to draw your eye to here is that by performing this type of stream restoration in this particular manner, we're actually reducing 110 tons of sediment into the Chesapeake Bay every single year by doing this work, which is roughly equivalent to about effectively 11 truckloads every single year. So massive amounts of sediment every single year. The other aspect that I want to draw your eye to that we're particularly excited about is the uplift in habitat complexity. So if you remember by looking through the stream walk, there really wasn't that much difference between one reach to the other. There wasn't much complexity in the types of riffles and the pools. What we're doing here is we're taking effectively a small subset and expanding on it, where at each one of these locations, we're facilitating the fast shallow or the riffle type of pattern, the fast deep, the run, the slow deep, which is the pool, and the slow shallow, which is effectively the glide. So we're particularly excited about this because it not only provides water quality improvements, but also uplifts this channel for the stream side and aquatic species as well. Now, the other great news is that the final objective that Dan outlined earlier, that being increasing educational opportunities, the way that we're performing the grading scheme here at this particular site is actually making a really easy pathway from the existing trail systems down into the stream network. They're really gentle slopes. And so by doing this, we can invite folks down to the stream who might not otherwise be there and learn about the importance of managing these really important assets. And so I spent a little bit of time walking through each one of the steps and the approach that we've taken, how we're taking our methodology and theory and applying it at this site. Now I'm going to hand it back to Ryan to talk through the timeline and the next steps for this particular project.
Great, thanks, Ty. So, I'm just going to ask if anyone has questions, please submit them through the chat. We're looking forward to answering whatever you'd like to find out or about our technical approach and what we're doing at Schenks. I should also acknowledge Schenks or Schenks, there's multiple pronunciations. I think we default to the easier one for us, but we know that it could be called multiple things. So Ty, on the next slide, we started this project with the field work. That's really the product of all the photos and videos that you've seen. We've worked through some preliminary technical memos and submitted a 50% design to the city. We would also, now's the time that we would like to hear from you. And we're pushing towards our 100% design submission. That's in April, and then eventually into construction. And this timeline is also being driven by the SLAF grant funding. So we're doing our best to make sure that we get within the timelines of that funding source. Please feel free to reach out, particularly take a look at the story map. I think it does provide a pretty similar thing to what you've seen tonight, and also provides Dan's email address. But we really appreciate you taking the time to join us. And Dan, is there anything else you'd like to say before we stop?
I just would like to echo your comments, Ryan. We appreciate everyone's time and joining us tonight, your interest in the project. Please feel free to reach out to me if you have any questions. I should have put my email on here, but it's quite easy to remember. It's my last name, Frisbee, FRISBEE @charlottesville.gov. Feel free to reach out to me directly with any other questions you have that might come up subsequent to the meeting. But thanks so much for joining us tonight, and we'll look forward to continuing our conversation, and really look forward to getting this project completed in the ground for the community to benefit from and enjoy.
Okay, thank you very much.